Okay, this is McGraw-Hill Chapter 1, Section 7, Absolute Value of Inequalities. I think on the last one, I forgot to change the section number on the board for Section 6. It says Section 5, but it is Section 6. But really on this, all we have to do is look at example problems and see what you're going to face. All right, so here's example 1, page 104. You have the absolute value of 3w plus 1 minus 4 less than 7. So the first thing we do is we add 4 to both sides. Now we get absolute value of 3w plus 1 less than 11. Because the absolute value is positive and 11 is positive, we can get values here that are less than 11. So we set it up. 3w plus 1 is less than 11. 3w plus 1 is greater than negative 11. Now see here, when you're doing inequalities, when you change the sign, you have to flip the inequality. So when I change this positive 11 to a negative 11, I have to flip the less than to a greater than. Now if I look at this, I can see that negative 11 is my smallest number. So I place it here. 3w plus 1 is the second. And then 11 is the last. See, I can join these two together because they'll work. So then I add 1 to both sides, divide by 3, then I get negative 4 is less than w, which is less than 10 over 3, which I can graph, and the interval is represented by parentheses, negative 4, comma, 10 over 3, parentheses. See, we can do this if we notice that our lesser number is a negative. That means that our algebraic expression goes in the middle, and then our larger number goes on the right. Here's example 2, page 105. We have 3 is less than or equal to 1 plus absolute value of 1/2 t minus 5. All right, so when we solve inequalities, we always want the variable on the right. You'll never see the variable written on the left. It's always on the right. So the first thing I did here was I took these two and flipped them. When I flip them, I have to change the inequality sign. So I took the 1 plus absolute value of 1/2 t minus 5, placed it on the left, put the 3 on the right. Got to flip it from less than or equal to greater than or equal to. Subtract the 1. We get absolute value of 1/2 t minus 5 is greater than or equal to 2. So now we can split it up. We have 1/2 t minus 5 is greater than or equal to 2. We have 1/2 t minus 5 is less than or equal to negative 2. Remember, when I change the sign of this, I have to also flip the inequality. Add the 5 over, 1/2 t greater than or equal to 7. Multiply by 2, t is greater than or equal to 14. Add the 5, I get 1/2 t is less than or equal to 3. Multiply by 2, I get t is less than or equal to 6. You can see that bracket 14 going to positive infinity, bracket 6 going to negative infinity. There's no intersection. So this is our solution. Parentheses negative infinity, comma 6, bracket, union, or bracket 14, comma, infinity, positive infinity, parentheses. So, in these absolute value problems, there's a combination of what we've learned in the first 2 or 3 sections. Special cases. You have to analyze the problem. And so example 3, page 105, gives you a couple examples on this. You have absolute value of 3d minus 5 plus 7 less than 4. So the first thing we naturally do is subtract the 7 over, which now gives us absolute value of 3d minus 5 less than negative 3. Well, remember the absolute value is always positive. So how can a positive be less than negative 3? It can't. So that's the reason it is no solution. In this one, we have absolute value of 3d minus 5 plus 7 greater than 4. Subtract the 7 over, we get absolute value of 3d minus 5 greater than negative 3. Well, because the absolute value is always going to be positive, then no matter what we stick in for D, it's always going to be greater than negative 3 because 3 is negative. So this is all real numbers. I can stick anything in here in D, and it's going to be 0 or positive, which is going to be greater than negative 3. You got to look at these cases. So on these absolute value inequalities, you got to look at them and analyze them, one side, left side versus right side, with the inequality sign to make sure it is a true statement.